Hey guys, I want to make a quick video about dividing polynomials. But I guess before I do, I should just remind you of the whole long division process with just regular integers. So say I wanted to divide 11 by 4. Then 11 is the dividend, it's the person being divided. 4 is the divisor, it is the number doing the dividing. So we're really asking how many times does 4 go into 11? Well, 4 goes into 11 2 times, leaving me with 8, or 2 times 4 gives me 8. After multiplying, I then subtract to give me 3, and I continue the process over and over and over again, right? Like, how many times does 4 go into 3? Well, in this case, it doesn't, so I'm done. I can say that 2 is really 11 over 4 is really 2 and 3/4. The quotient plus the remainder over the divisor. So the same process is going to hold for polynomials. The only thing that I want to bring up is that in this case, 2 plus 3 over 4 is the same as 2 and 3/4. So when we divide polynomials, we can't put polynomials together like this. We have to use the operation. Okay, so let me show you an example. Let's just start off with something nice, like say I wanted to divide x squared plus 3x minus 2 by x plus 1. Okay, so same as before, the setup is the same at least. X squared plus 3x minus 2 goes on the inside. X plus 1, that's the divisor, that goes on the inside. Notice though that the problem is I can't really answer, or I can't really ask how many times does x plus 1 go into x squared plus 3x minus 2. So that's not really the way of thinking about it anymore. The difference is now I'm looking just at the first terms. What times this first term gives me this first term? What times x gives me x squared? Once you recognize that you need another x times x gives you x squared, then the other thing you have to be careful of is you're multiplying times this whole expression now. Before it was just a number, but I'm multiplying x times an entire expression, so I have to distribute it to each term. X times x gives me x squared, and then x times 1 gives me positive x. So I'm multiplying times each of those. Then, the same as before, I subtract, but again, you have to be careful because you're subtracting a whole expression. So if you did this correctly, the first two terms will match, they'll always cancel out. One mistake that I think a lot of people make, and a habit that I want you to try to break, is they try to distribute the negative through to each term. I don't think that's a good idea. Instead, I think it's much better and much nicer to write it off to the side. 3x is my first term, it's a positive 3x, minus a positive x. So that becomes 3x minus x, which is just 2x. That way, I can keep the interior of my division looking nice and clean. After you do the subtraction, then you repeat. You say, okay, what times this first term gives me this first term? What times x gives me 2x? Well, in this case, it's a positive 2, so I'm multiplying positive 2 times x and positive 2 times 1. That gives me 2x plus 2. Here you have to be a little bit careful. It's very tempting to think that they cancel out, but really I have negative 2 minus a positive 2, which is negative 4. So then I continue. I say, what times x gives me 4? And I see, hey, I can't actually turn an x into a 4. I can't go down in any degrees. So that's my remainder is negative 4. X plus 2, that's my quotient. And then since I have a negative 4, there's two ways that I could write it. I could write it as minus 4 over x plus 1, because if the negative's out in front, it belongs to the numerator. Or if you prefer, you could always write addition as the operation between them, and then just put whatever the remainder is in the numerator. So those are two different ways to write it. I think Math Excel might, well, actually, we'll take each of them. Sometimes it asks you to write them separately, but I think for the most part, they want you to do it together. So either one would work. I think writing the negative out in front looks fancier, but this is totally acceptable. And so then the nice thing about it is you could always write plus whatever the remainder over the divisor is. Remember, the divisor is always going on bottom, so I'm getting x plus 1 on bottom because of this x plus 1 here. All right, so let me show you one more. say I want to divide x squared plus 2x plus 3 by x minus 2. Usually when there's subtraction happening, then it becomes a little bit more difficult to see the subtraction in your head. So this is where, again, I would do a lot of the work off to the side, outside of the house. X squared plus 2x plus 3 goes on the inside. Maybe I should write my box a little bit lower. X squared minus 2, that ends up on the, x minus 2 ends up on the outside. So again, same first step. What times x gives me x squared? What times the first term gives me the first term? Well, it's also just an x. So when I distribute through, I get x squared minus 2x. Be very careful with the subtraction. The first step will always cancel out if you're doing everything correctly. X squared minus x squared, fine. There's no real need to distribute the negative through. Just take this part very carefully. 2x minus a negative 2x. And if you have to, write it out. 2x, then minus, then negative 2x. Well, that's 2x plus 2x, which is just 4x. After you do your subtraction, you just bring everything else down. So you bring the positive 3 down, and you repeat again. What times x gives me 4x? What times the first term gives me the first term now? Well, it's a positive 4. So that I get 4x minus 8 when I distribute the 4 through to each of them. I'm putting parentheses every time I do subtraction to remind myself that the negative belongs to each of them, but I'm not distributing it through. 3 minus negative 8 gives me 11. 3 minus negative 8 is 3 plus 8, which is 11. So that I end up with x plus 4 plus 11 over x minus 2. This was the quotient. This was the remainder. The divisor always goes on bottom. Now, you do have to be a little bit careful, because if there's terms missing, you should use placeholders. You don't always necessarily need them. Like, say I have 3x cubed divided by, 3x cubed minus 4x squared minus 4, and I want to divide that all by x minus 4. Well, then x minus 4 still goes on the outside, but on the inside I got to be a little bit careful. 3x cubed goes first, minus 4x squared, but there's no x term. And so maybe I'll need it, because I might end up with an x term when I multiply through, so I'm going to put a plus 0x here, minus 4. Alright, so really these are two same expressions. I just put a 0x there because 0x is still 0. It doesn't change the whole polynomial. But then the question is, what times x gives you 3x cubed? That's a 3, will give me the 3 out in front. And then what times x gives me x cubed? That's an x squared. So when I multiply by 3x squared on both, or to both terms, I get 3x cubed, just like I wanted, and then minus 12x squared. When I subtract, these two cancel out. There's no need to really think about them. Here's where I should be careful. Here's where all the mistakes happen. Negative 4x squared minus negative 12x squared. Well, I'll write it for a second. Negative 4x squared minus negative 12x squared. And what you see is that the addition, or the subtraction, becomes addition because of this double negative. So it's really negative 4 plus 12, which is 8x squared. So let me get rid of this. I'm going to need the space, so I'll write this as positive 8x squared. Negative 4 plus 12 is positive 8. Now there's still two terms here, so I'm going to bring them both down, 0x and negative 4, and then repeat the process. What times x gives me 8x squared? This case, it's just a positive 8x. So that I get 8x squared minus 32x. The good thing is that I put that 0x there, I put that placeholder there so that the x terms line up. Like imagine this wasn't here, this -4 would be there, and I can't subtract the 4 and a 32x, so it messes things up big time. So it's really nice to put a placeholder in case you need it. It's better to have it and not need it than to not have it when you do need it. The 8x squareds cancel out. 0x minus -32x, they're both x terms, so I can subtract them. Well, really, 0 minus -32 becomes positive 32, so this is positive 32x, and then I bring the -4 down. Now to finish up, I ask myself what times x gives me 32x. That's a positive 32. Well, 32 times x is just 32x. And then 32 times -4 gives me -126. So that when I subtract, the 32's cancel. -4 minus -126, that becomes -4 plus 126, which is positive 122. And that's my remainder, so my answer is 3x squared plus 8x plus 32, that's what I got up top, but then don't forget you have to put an operation, and since it's positive, I'll just use plus 122 over x minus 4. The only time I would use a subtraction here is if it was negative, and again, you don't even have to. You could just put the plus and put the negative up top. Let me show you a case, though, where you don't necessarily need the placeholder also. The previous one was just like the one on Math Excel, but I want to show you an extra case. Like maybe I give you something like 3x cubed, sorry, minus 4x plus 1, and I want to divide by x squared minus 1. Well, then just like before, let me put the x squared minus 1 on the outside, and let me put the 3x cubed plus 0x squared this time, because there's no x squared term, minus 4x plus 1. Notice that I'm not putting any placeholders on the outside. You really only care about the placeholders on the inside. So when you ask yourself this question, what times x squared is going to give you a 3x cubed? Well, I need the 3, but I also need to go up 1, so this becomes 3x times x squared, giving me 3x cubed. Then 3x times -1 gives me -3x, so that I subtract this whole expression. Here's the problem, though. If I just put them next to each other back to back, I end up with an x squared term and an x term. These aren't actually like terms. I can't actually subtract them. So I should go back a few steps and say, well, I put that placeholder there in case I ended up with a in case I ended up with an x squared, but when I distribute the 3x through, I really get -3x. I should line that up with the x terms. I still am subtracting this whole expression, but the point is I don't really need this placeholder. It wasn't useful for me. So the 3x cubed and the 3x cubed, they cancel out, but the -4x minus -3x, that just gives me positive x. The only thing left to bring down is the positive 1. There's no need to bring the placeholder down because I didn't need it. So I just put it away. Then I ask myself what times x squared gives me an x. Well, I can't go down in degrees, so I'm done. I get 3x plus the x plus 1 over x squared minus 1. All right, so sometimes you need the placeholders, sometimes you don't. It's a good idea to put them rather than not have them and need them later on. The biggest thing to look out for is that as you're multiplying, you're lining up the terms correctly. So the x cubed term went under the x cubed term, the x term went under the x term, and then I didn't have anybody for x squared, so I just threw it away. All right, try out the problem on Math Excel. Let me know if you have any questions.